Hello, today we're going to be looking at section 9.2, which is about translations. A translation is one of the isometries that we discussed in a previous lesson, meaning that the pre-image and the image for every translation are congruent figures. A translation you better know as a slide. It takes a figure and moves it up, down, left, right, or a combination of those directions. But each vertex, each part of the figure gets moved the same direction, the same amount of space, the same distance. When we write a translation on the coordinate plane, the translation gets written like this, where we show a rule for what happens to the x-coordinate and to the y-coordinate of each point of the pre-image in order to get the image. X plus A represents the horizontal distance, either left or right. Y plus B, the B represents the vertical distance, or the amount that the figure moves up or down. We can also show translations in terms of a vector that we moved or learned about the other day. Remember, a vector looks something like this. When we write a translation in vector form, it shows again the horizontal and the vertical shift or slide. If we take a look at two examples, it says graph each figure and then its image under the given translation. So there are two different ways to do these questions, and you can do whichever you prefer. So I'll show you each method for the two different questions. So question number one, we're taking line segment DE, and we're going to perform the translation. XY becomes X plus 1, Y plus 3. In other words, this means that we're going to move to the right 1 space and up 3 spaces. So the first way to do this question is to count and use your graph to move each vertex up 3 and right 1. So if I use that method, point D can go to the right 1 space and up 1, 2, 3 spaces, so that D prime will end up here. If I count the boxes again, E would go right 1 space and up 1, 2, 3 spaces, so that E prime ends up here. Again, we wouldn't show our bunny hops, so the final graph would look like this. For each of these questions, you should show the coordinates of your image. So D prime, if I count the coordinates, ends up at -2, -1. And E prime ends up at the coordinates 5, 5. So the first way to do each of these questions is to use your graph, count the boxes, and move each vertex accordingly. In question number 2, we're given triangle KLM and asked to move the triangle along the vector -3, -4. This time, that means that we're going to take our graph and move each of the points left 3 and down 4 spaces. So instead of using the graph, we can also do this algebraically. So if my original point K is at the coordinates 5, -2, I can add the x-coordinate to our vector and add the y-coordinate to the y-coordinate of the vector to find the new coordinates of K prime. So K prime is going to be at 5 minus 3, comma, -2 minus 4. Which means that K prime is going to end up at the coordinates 2, -6. If I use the point L to find L prime is going to have an x-coordinate of -3, -3, and a y-coordinate, -1, -4. So L prime should be at -6, -5. And using the coordinates from M and our vector, M prime should end up at 0, minus 3, comma 5, minus 4. So M prime goes to negative 3, positive 1. You still then need to plot the points and show the graph, but this is the other method. So K prime is now at 2, negative 6, down here. L prime is negative 6, negative 5, and M prime, negative 3, positive 1. As I mentioned, translations are still isometries, so your original figure and your image should look exactly the same, just slid over, up, down, left, right. Question number 3 says, triangle XYZ has vertices at x is 5, 4, y is 3, negative 1, and z is at 0, 2. The triangle gets translated so that x prime ends up at 3, 1. Find the coordinates of y prime and z prime. So instead of giving us the rule for this translation, we need to find the rule first using x and x prime, and then we can apply that rule to y and y prime. So if I start at x, I can see that I have to move over 1, 2 spaces to the left and down 1, 2, 3 spaces to get to x prime. So from x to x prime, I can use the rule x comma y, the original coordinates, become x minus 2. So that indicates that we went left 2 spaces, comma, y minus 3 to show that we went down 3 spaces. Once I figure out my rule, I can then apply that to the coordinates for y and z. So now if y was at 3, negative 1, y prime, applying the rule, is going to be at 3 minus 2, comma, negative 1 minus 3, which means that y prime will go to the point 1, negative 4. Z was at 0, 2, so z prime is going to be at 0, minus 2, comma 2, minus 3. So z prime should end up at negative 2, negative 1. Let's plot these two new coordinates so that we can see if they are in fact correct. So y prime, we said, was at 1, negative 4. Z prime is at negative 2, negative 1. And if we connect those back to x prime, we can see here that the pre-image and the image are in fact congruent. So this looks correct. Okay, when you flip your notes over to the other side, the last two examples are showing you how to perform a translation on just a blank sheet of paper, not on the coordinate plane. Like the other day when we did this with our reflections, it's going to be a little bit tricky to show you digitally, but I'll do the best that I can. You are going to need a ruler for this one as well. So if you don't have one, you should pause and grab one now. So up at the top, to draw a translation using a vector, it says draw a line through each vertex parallel to your translation vector. So when I look at this picture, number 5, I'm going to take triangle PQR and I'm going to translate it. I'm going to slide it over. And the vector here, so vector V in this case, tells me not only how far I'm going to slide the triangle, but also in what direction. So the first thing we do is we start by creating lines parallel to our vector through each of our vertices. So from line R, from point R, excuse me, I'm going to draw a line as best as I can parallel to our translation vector. Then another parallel line through point Q, and a third parallel line through point P. You should, of course, use your ruler to do this. We're eyeballing it, so there's definitely human error involved, but that's absolutely fine. Okay, then you're going to take your ruler and you're going to measure vector V. Make sure you measure from the end of the vector all the way to the tip of the arrow of the vector, from the initial point to the terminal point. I like to measure in centimeters simply because they're broken up into tenths, so it's easier to work with. So when I measured this on my actual piece of paper, I measured vector V to be about 1.6 centimeters long. So now we're going to take each of our vertices and we're going to slide them along our parallel lines up and to the right, just like our vector points, and we're going to move them a total of 1.6 centimeters. So if I were to start with point R, you would now put 0 centimeters on vertex R, measure out 1.6 centimeters, which should look something like this. And here's the new point, R prime. Then translate point Q. So from point Q, I'm going to measure along my parallel line that 1.6 centimeters to find the point Q prime. And then from point P, again, measure along your parallel line 1.6 centimeters to find P prime. Once you connect your new points, remember that this should be an isometry. So your pre-image and your image should be the same. As you can see on my drawing, it's not perfect. There's definitely human error involved, but it's pretty darn close. I would say this is good. Okay, so our last example, we're going to take this quadrilateral and we're going to translate the quadrilateral along vector Y. So again, we're going to start by drawing a line through each vertex parallel to line Y, and just do the best that you can. To some extent, we're eyeballing it. As you can see, my first try wasn't very good here. All right, let's try this again. That's pretty close. Okay, one parallel line through each of your vertices. Okay, then you're going to measure vector Y all the way from the initial point to the terminal point. When I measured this on my actual paper, I came up with about 2.2 centimeters. Then you're going to move each of your vertices individually. So from each vertex, measure down and to the left, so along your parallel line, 2.2 centimeters. So when I measure from point B, B prime ends up about here. 2.2 centimeters from C should make C prime about here. When point D moves, it should be approximately here for D prime. And A prime should be around here. connect the points from your new vertices. I still like to shade in my image. So let's move my label 55. And again, not perfect. Definitely some human error, but you can see this looks like I slid the quadrilateral along the vector in the same direction, the same length as the translation vector. Okay, the homework is the worksheet that's associated with this lesson, 9.2. You should have that in the packet that I gave you at school, or we also have it attached to this assignment. Please let me know if you have any questions. Have a great day.